we are back.
Excellent.
Yep, back.
Any questions, guys, with the first steps using Trimble Cloud Engine?
Just one quick question, just to clarify. So your raw point scans that you pick up from the site, you save it in your case on your D drive, correct? And then the selected scans, you bring them over to your local C drive, and then you kind of clean them up, then you bring them in whichever scans you need. Is that correct? So you're working locally, the model and your scans that you're going to be using or filtering for the Cloud Engine are going to be on a local C drive.
Yes, all the scans have to be on the local C drive.
Not, you mean not all the scans you'll be using for this
yes,
case.
the scans we'll be using, exactly. So
Okay.
I just selected 9 out of 19 for this project, so I could have only had the 9 first scans on my C drive, but as a group, they were all in the same folder. I brought the entire folder in.
Okay, thank you, JP.
No worries. All right, so what we've done up to now, step number 1 and step number 2. So step number 1, we created our project. So we made sure we created a subfolder in the or in the Bloom CE folder that I did a subfolder that I called EML training. And this is where I pasted my TZF scans and my model files. I then inside Cloud Engine created my Cloud Engine project, imported my raw scans, very, very important. As soon as the import was done, I come in my object list, I group the 9 scans and I lock the 9 scans and then I group them. So I create a branch that I can move around without breaking the registration or the position or my puzzle. So very, very important to do this. Lock the scans, group the scans. This is step number 1. Step number 2 was importing a background file, a CAD file or a CAD model inside Cloud Engine, and lining up that point cloud over that model. So there's 3 ways to go about. We can do manual positioning, can do best fit, or we can do a georeference. You guys have the tools and the skills to use a total station, so you could go and do a georeference. If this is something you want to do down the road, give me a shout. I'll give you the steps, the guidelines on how to be successful when doing this, and then I can guide you in Cloud Engine. In my mind, a manual positioning is as accurate as a best fit or a georeference, and it also gives us a little bit more flexibility. Best fit will distribute the error amongst all of the points, as opposed to manual positioning. I can decide to set a column or the end of a flange or a wall to be my start point. And georeferencing, though, has the advantage of always being on the same datum and eliminating that uncertainty, if there is a small one, of manual placement every time. So if we're doing analysis over time, or we want to do some checks over time and always want to be sitting on the same datum, we will want to do a georeference. All right, so once we got our point cloud line up against our model, we will lock our branch so nothing moves from now on. Step 1 and 2 are not completed. We have 3 and 4 left to do, and you'll see that they're pretty easy and pretty straightforward to do. So now we want to clean this point cloud up a little bit. As you can see, we did 9 scans and we got some points that were collected for farther out. And our only area of concern here, if I zoom in and enter this point cloud, is really this boiler or this chiller that we need to replace in the back here, right? This is what we want to focus on. If I bring all of this inside Revit, going to be a pain. You can see we don't see through the roof. Maybe I don't need the roof. I don't need those points over here. I want to clean this point cloud up a little bit. So I'm just going to give you a few things or show you a few things here. So the 9 scans that we imported here, I went to the points details menu. By the way, I was quick on that. Sorry for that. So I went to the points details menu, which opened the point cloud management tool here. And it tells me that I got 100 million points available. The 9 scans all combined together represent 1 million points, but I'm currently viewing 5.1 million on my screen. So Cloud Engine will render a sample or a downsize point cloud that suits your computer hardware. So it will look at your processor, your disks, your disk and your RAM and your graphics card and say, well, if I render 5 million points, you'll be able to zoom in, zoom out, rotate. It's going to make sense. You guys saw that it was easy when I was driving it around, and I can still understand that we've got walls and ceilings and pipes and stuff like that and columns with 5 million points. That's cool. It's going to be a lot easier to manage 5 million points inside Rivet than 100 million points. So if I take the data directly out of the tablet, I could, in theory, put it and use it in Rivet right out of the tablet. It's registered and it's ready to be worked on. This is the sole purpose of Cloud Engine. It's to line up the point cloud over your model and reduce the number of points, optimize your point cloud. So as you can see, 5.1 million points are visible. So when I zoom in, you can see that there's a bit of spacing between the points, right? They're not like super tight. Let me find a nice place to look at it. See, we can see this sparse a little bit. You know, it's not very dense, but I got preset views that get calculated. So I can click on this green bar, the second green bar, and it's going to upload or display close to 20 million points. See, now I got way more points. It's looking way better, way cleaner, but it's 20 million points now, not 5.1. So you always have 2 preset views that are available for you, and they're ready. They're in the memory, and they're ready to be toggled on or off. If you want more points, you can always, or less, another different number. If you're like 5 is not enough, 20 is too much, I want to go in between. You click on the bar in between and you say create details. It's going to go back to the database and load in more points or adjust the number of points. So now I'm viewing 12 million. I got my 5.5 million, 12 million points. I want more than 19, I can click on this +5 here to add more bars, and I can say, let me drive it down all the way to 31, let's say. This is a guesstimate. It's probably going to be more than 31. So what's it doing when you click create details? It goes back to the database, which is local, and uploads those points to the memory. So if you're working on your network drive, this is where the path to the data takes forever. And you guys are gonna be, boy, is this ever so long, so long and so slow. It's because the path to the data to get it back to the memory is longer. So now we're viewing 57 million points. So if I zoom out, you can see that we got more points on the ceiling. Rendering is a little bit more choppy. I don't know if you notice it on your end, but I do notice it. But you guys might remember these pipes here were pretty scattered in points at the beginning. Now we can see them like, wow, it's almost like a picture. But if I bring it back to 5.1, see how they got way less points. So depending on what you want to be doing, you're going to be adjusting the number of points. If I'm just running a new pipe and I want to make sure I'm not clashing into those guys here, I don't need 60 million points. But if I'm redesigning those pipes and I want to have the flange and where the elbow is, because we're going to cut it here, this is design or detailing, then we probably want to have more points to have a better representation of this. So this is how you play with your number of points with Cloud Engine. So now we're going to clean this point cloud up a little bit. Like I said, our only area of concern is here. The rest, we don't care. So here's how we're going to optimize the point cloud. Optimizing the point cloud will get rid of the low quality points and only keep the high quality points from a scan. What's a low quality or a high quality points in laser scanning? If I'm doing a scan in front of the wall in the room where I'm sitting in, the points in front will be very high quality because they're hitting the wall and they're coming back to the scanner in a perpendicular angle. It's hitting the walls, coming back to the scanner. Those points will have strong normals. The normal is the point in which the direction, or is the direction in which the point was collected. I'll put the words in the right order, sorry about that. Is the direction in which the point was collected. That's the normal. So as I'm scanning, I'm doing a 360, right? And I'm moving and I'm collecting some points at the other end of the wall, 20 meters down. that point is going to have a weak normal because the direction in which it was collected is in an oblique angle. So it's not going to be a very strong normal. But 20 meters down, I did another scan in front of this location. So now I have a mix of high quality and low quality points. So Cloud Engine is going to do that job for us and get rid of the low quality points and only keep the high quality points. High quality points will allow us to do nice deviation analysis, make our life easier when we're doing selection, point selection, measurements, and all of that stuff. So that's the stage that we want to reach every time we bring in a point cloud. We want to get to that optimized node, and this is where we're going to start to export to Revit or do some analysis. So how do we create this node? It's using a clipping box. We're going to focus on a certain area. So what I'm going to do, I'm going to flip back to a top view here. I know my chiller is in this area because I see my scans and I know it's in this area. So I want to do a clipping box. So I'll go to display, model view. But you can see it's still on the last clipping box that I did for my elevations adjustment. So it's a tiny clipping box and I could grab the manipulators and make it bigger, but I'll show you a few tips and tricks on how to be a little bit more efficient with the clipping box here. One of the concepts we have in Cloud Engine is selection, action. What if I select my model and I ask the software to reset the clipping box? Selection, action. What's selected? My model. Reset the clipping box. See how it resets the box? Just around my model. Super easy now. I can click and there you go. This is the area I'm working in. I didn't have to take those manipulators and move them all the way in and, waste some time. I was efficient. So if I go back to top view here, release the clipping box, go back to top view, let me select the raw scans, reset the view. You see how it makes this big clipping box? Because I got points kicking around. I got crazy points or loose points way over there. So that's why the clipping box is so big. Then I'd have to take this, bring it here. Oops, it's a little bit too large. Selection action, model, that's the area I want to work around. Clip, toggle the clipping box, and there you go. I'm pretty much done. This is the area that I want. Well, maybe I want a little bit larger. You can just make it a little bit larger, wider, whatever. And we were super quick to make this clipping box around our select. Maybe I want to raise this up. All right, so this is the area that is of interest for me. I need to, there we go. We'll put a little bit more steel in front. This is my area of interest. That's what I want to optimize and send to Revit. So clipping box around the area, you go to the points menu, and then details. And then in my toolbox, I got 3 tabs. One of them is optimize. So I'm going to go to the optimize tab and click on this little button here. It can be not obvious to see that it's a button because they didn't put an outline to it. But if you hover over it, you'll see that it's a button. So we're going to click on this and it's going to clean or optimize the point cloud. You can see that it's working on the point cloud and it's going to create, you'll see in a few seconds here, a new object. That's going to be called optimize data. There you go. If I let go my clipping box, you can see here this last icon is in blue. This means I have a current, or I have a clipping box that's activated. We don't see it anymore because we optimize what was inside, and this is what we're seeing. But if I let go of the clipping box, we now have our point cloud. So if I go back to details, you guys remember when we started with the raw scans, we had 100 million points. 100,000 points. Sorry about that. That's my French. French being my first language, I get those numbers wrong in English every time. One day, I hope I'll be good. So what happened? We created this new object. You see here, it's called the selected object. I can rename it and call it chiller. Now this chiller object has went from 100,000 points to 46 million points, or 100 million points to 46 million points. a lot more easier to manage in Rivet than the full point cloud. And we're currently just seeing 300,000 points. Not a whole lot, but still get the gestics of it, you know. This is just to check for clashes. I don't need more points. This is what I'm going to export to Rivet. There you go, we're done. Oops, no, it's design work. I'm going to load more points. One thing that also happened, you can see how the points are now. Let me show you the walls here in the back. You can see how the points are all lined up like little soldiers, squared up. The software didn't move them. It just got rid of those low quality points and made that grid of points of high quality. So if I now load close to 1,000,000 points, you see you got more points. The spacing is smaller, tighter. If I want to load more, I can click add more bars, click create details. It goes back to the database. Now we see the coasting in the aluminum sheeting now because we got more points that were loaded. So that's how you play with your number of points, and that's how you get the point cloud optimized. All right, so we created this first node, which is cool. But I still want to clean it up a little bit more because you see you got people that were standing in the way when we scanned, and maybe there's a few things I'd like to clean up. So how do we delete points or clean it up a little bit more? Because when we started with a clipping box. It's kind of like pretty restrictive. It's just it's a cube or a rectangle, and you get what you got in that rectangle. Now I'd like to get rid of those guys sitting here and clean this point cloud a little bit more. So for this, I'm going to go to the select menu under select points. Different ways that we can select points in Cloud Engine. We can do a window selection, a polygon, a lasso, or a paintbrush. The first three, window, polygon, lasso, the point selection is going to cover the entire depth of your view. So if I want to get rid of this buddy here, this guy here, let me turn off the markers. So here you see those are the station markers. I'll hide them. We don't need them. I feel they're a little bit in the ways. So I want to get rid of this guy here that was in the way when we did the scans. So if I go with the window selection and say, all right, let me draw a window around this guy, see how it's selected the points all the way or in the entire depth of my view. So it's selected all the way back to the wall and the pipes. I don't want to delete those points. I just want to delete this guy here. So every time you do a window selection, a lasso or polygon, this is what it does. So you either have to be smart and say, all right, I think that if I rotate like this, put myself like that, and I box this guy out, see, now I just got the guy because I had nothing in the back of my field of view. So I just selected this guy. So this is one way to do it. You could hit the delete button here. Now he's gone. But I got a few other guys here, so I'm going to show you a few other techniques that we can use. So I'd like to get rid of this guy here. There's a guy here standing in front. Might not see it very well. There's not a lot of points. You can see it here. This guy I want to get rid. If I use the paintbrush, the paintbrush is only going to select the first layer of points that you see from your perspective. You can see the size of the paintbrush, pretty small. Maybe I want to make it a little bit bigger. You can increase its size and you see how it became bigger. Now you see when I'm brushing, it's only selecting the points from the first layer. So if I turn around, no points were selected here on this pipe, despite the fact that they were in my field of view. I was brushing like this, so no points were selected here in the back. So this is the difference between the paintbrush and the other rectangle or lasso or polylines that we can do. So I could hit delete here, and you'll see it only deleted the points here in front. That's another way to do it. I'll show you another way to be efficient at deleting some stuff. This guy here, I want to delete. Here's another quick trick I like to do. I go to the paintbrush, I brush the bottom, the top, a few places, and then I hit the F8 key on my keyboard. The F8 key on the keyboard, when you have selected points, will fit a scope box around your point selection. So I hit the F8 key, sorry, There you go. It fitted a scope box around my point selection. So at this stage, it's pretty easy to come and adjust the size of this clipping box. Lower it just a little bit. Now I'm not on the floor. There you go. Now I'm going to hit the backspace key. You'll see it's going to unselect. Backspace only unselects, it doesn't delete. So now I've isolated this guy. I can go back to a window selection, box him out, delete, let go of the clipping box because I want my stuff to come back, and you see this guy's no longer in the ways. So different ways to work this out and to clean the point cloud. All right, so paintbrush, this guy, I want him to go. Brush his helmet, brush his steel shoe, and then just adjust the size of my clipping box. I do want to keep the floor, so just going to raise this up a little bit, backspace to clear my selection, and box him out. There you go. No longer there. All right, so this is how you optimize your point cloud for a specific area and how you delete people or objects in that node that you want to do. Now, I'd like to create another node, another optimized object that's just going to be around these pipes here. So what we're going to do for this, we are going to hide this here. We're going to go back to our raw scans. Our raw scans are always available. You notice that the points I deleted them in the optimized node. If I would have deleted them in the raw scans, they'd be gone forever. That's not the way I want to work. I want my raw scans to always be available for me, because at any time I can go back to my raw scans and create more nodes, optimized nodes. So let's go back to our branch, which is the raw scans, and home the view, and where are the points? They're not visible. What happens when we create a node? The raw scans get unloaded from the memory to give us more RAM and to make us perform better when we're doing deviation analysis and working on our optimized node. So like I said, every time we start a project in Cloud Engine, the endpoint, our goal is to get to that optimized node to make our life easier and to work better. So I go back to my raw scans and they're no longer available. You might not have noticed, but these symbols in front of the scans before we created our node were black. Now they're pale gray, meaning they've been unloaded from the memory. So what you do, you click on the branch, you right click and you say reload. They're still in the database. They just need to be reloaded. There you go. I got my full point cloud back. And now I could decide that I would like to do another clipping box, but this time around, I just need the head of the structure. Just that's the only thing I need to work on is the head of the top structure. Nothing else for me matters. Well, I'm going to do a clipping box that's going to be around this area. So quick tricks that I showed you to create clipping box. Either we make the model visible, we select it, we go to display, model view. Let's reset the clipping box around our selected object. This is one way to do it. Other way to do it, go to select points, use the paintbrush. Say I need to go from here to here, brush a few points, F8, there you go. You got a clipping box that you can quickly adjust its size after the fact or afterwards. We're just looking to get the top structure here like that. We don't need to go outside, bring it in like this. And this, we don't need more than that. All right, this is what I need. I'm all good. One other thing I can show you guys, I think it's very important. That clipping box, if I go to the display tool, model view, is always a rectangle, right? And it's squared with my plan north. It's going upwards. I can scale it, but there's a few other things I can do with the clipping box. So I can move it around with a gizmo, just like the transform tool. So you can see I'm moving it wherever I want. So I can use it with the gizmo. I can move it with my arrows running along the axis. I can rotate it. this is what I wanted to show you guys. So if you got this part or this pump that's like sideways on your point cloud and you're like, how the heck can I fit a scope box just around this element? Fit the scope box, rotate it to how you want it to look, and then you can go to the scale and then you can make it bigger or smaller. So those are key things I wanted to show you around the clipping box, because some people get kind of frustrated because the clipping box is always a rectangle that's squared north, right? So I got my clipping box. I'll go back to my points menu because I want to optimize this area. So under details, optimize menu, and then create, you'll see they're solid black. Once the object has been optimized, they'll get unloaded from the memory. See how they went pale gray, meaning they're unloaded from the memory. And we've got this new node, and we could say top racking, whatever, give it a name. So this top racking now contains 31 million points, and we're seeing 250,000. And then we could go on and clean it and do whatever we feel like doing around this. Any questions around the optimization process inside Cloud Engine?
All good. Yeah.
All good. So that can be useful. If you're going from one flange to the other flange and you don't really care what's in the middle, you could create two nodes, one for the beginning, one for the end, without having any points in between them. Because the two nodes are coming from the raw scans, the mother scans, and everything's locked down, despite the fact that they're not connected with points, they're true to each other. They're in absolute position one to each other. And you can take dimensions and they'll be right. If you move the node afterwards, then you're putting yourself in trouble. But if you don't move them, you have two separate chunks of the point cloud that are in absolute position. They're true to each other. It's going to make your life a whole lot easier in Revit. Let's release the clipping blocks. You see, I went and I have hidden our top racking and made our chiller visible, but because of my clipping box, I don't see my full chiller. So now I see my full chiller. All right, so now I'll show you another cool feature that we have. Will it work? It will work to some extent. All right. To clean up the point cloud, especially in as-built conditions, we can do this, and I really like it because we have a model, we have a scan, we can clean up our point cloud very quickly without having to do clipping boxes and then deleting people that are in the ways. So you always want to do this from the optimized node, not the raw data, because like I said, if you delete points in the raw scans, then they're deleted forever. You can always reload the raw scans, but I don't like wasting or waiting for scans to reload. 9 scans took 2 minutes, not the end of the world. But if you have 50 scans, it may take 10, 15 minutes. You don't want to waste 10, 15 minutes of your time. So what we're going to do here, what I'll show you guys is this chiller. I'd like to keep the points that are very close to the structure and those pipes, and the rest, I want to get rid of them. I just want the points that are within a certain distance of my model. So what I'm going to do, because I don't want to delete this object here, I'm going to duplicate it. So I'm going to click on the chiller and I'm going to say duplicate. Now I've got a new object. It put it under shapes and objects because it was deleted, but I can bring it back on top. So I'll call it chiller clean, and I want to bring it back with the rest of the people. So what you do is you select it, and then you right click on the branch where you want to put it. So if I click on optimize node, right click, and I say group under, you see how it went from shapes up to my optimized data. So I'm going to hide this first one, and I'm going to look at my chiller clean. Now what I want to do is just keep the points that are within the specific distance of the model. What you do for this is you right click on the model. So you right click on the model and you say select by shape. And then you can select points that are within 1, 2, or 6 inches of your model. So let's go with 6 inches for now. And you'll see the software is going to do the point selection for you. Shouldn't be too long. And all the points that are going to be highlighted are going to be within 6 inches of our model. So that's a very, very quick way to clean up a point cloud. Our steel fabricators, they love this because when they're outside scanning a warehouse and they've got a bunch of crap and zoom booms and people walking around, they just want the points around their columns to check their as-builts. They bring the IFC model, they line up the point cloud over it, they do a selection by shape, and then they say, poof, delete the rest. And they only keep the points that are within their structure, and then they can send it back to Tekla or Revit and do whatever they need to do. One thing I forgot to check is the number of points. I usually try to run it on a lower number of points because it's quicker. Sorry about that, guys. It's almost done. It's not progressing, but it's almost done. Any questions in the meantime? All good. All right. So, forgot to check the number of points I had. Remember, I'll give it a few seconds, but if it doesn't, I'll just kill it and restart it. You guys remember when I was talking about bringing in the model that has just a strict minimum? And I was talking about bolts, washers, and all that stuff. This is probably not the case here, but I see flow fitting and stuff like that. So what this analysis is doing is going through all of these objects and seeing if there are points that are 6 inches of that, all of these objects. So if I had 60 bolts, washer, and nuts, 60,000, it will do 60,000 operations and see if there are points close to those objects. So this is what I want to highlight when you're bringing in a model, just bring in what the strict minimum. So then it makes it a little bit quicker. If for some reason we would have had like a bunch of fittings here, small fittings, we could delete it. We can go click here, say delete, and it's going to delete that layer. If we forget about it, you're like, oh gosh, I got it exported. Guy exported it for me, and then the guy's off on vacation or he's busy, he doesn't have time to do it. You can delete it from there, no problem. It kind of gave me a bit of hope as it was progressing, but it didn't progress very long and it stopped. So what I'm gonna do is kill it. Just kill the program and I'll restart it. And we'll redo it. You'll see it's gonna be a lot quicker when I reduce the number of points. Got caught last week on a demo doing the same thing. One day I'll learn. All right, Cloud Engine is back up and running. So in our history, we're in our root folder. Gonna open this project up. So we didn't lose too much. You see I still have my chiller clean. So let me go to points. Viewing 10 million points. Bring it down to close to 300,000, which is less points. It's gonna be quicker. Select this, select by shape, 6 inches. There you go, a lot quicker. Sorry about that, guys. So all the points that are selected, you can see are highlighted. I can hide the model, you can see it a little bit better, are within 6 inches of this model. So what we'll do at this stage, let me reduce the size of my points a little bit. these are the points I want to keep. So if I go to my select tool, select points, and I hit delete, I'm deleting my selected points, not what I want to do. What I want to do is invert the selection with this magic button here. So I'm going to click on invert selection. Now you see how it inverts the selection, and then I can say delete. And there you go. I only have the points that were within 6 inches of my model. If I turn this model back on, all the points that we're seeing are within 6 inches of the model. That's another way to clean up the point cloud very efficiently. All right. At this stage, what I'm going to show you guys is a bit of modeling that we can do. So inside Cloud Engine, we don't have a lot of modeling tools. We don't have fittings and flanges, and I don't know if you guys use Siskiyou as a database inside Rivet, but we don't have all of those fittings and fancy stuff that you guys use to detail. But we can model basic shapes that will help us find the right balance between points and models. I sometimes talk to new customers that are just got their scanner, and their thought is, I want to convert the point cloud into a solid object. Everything I need to model into solids. And once they understand how to work it out with Cloud Engine, they say, all right, it makes sense. Because converting this entire point cloud into surfaces or shapes is going to take forever. It's going to be very time consuming. And the added value of having all of this point cloud into shapes is not that beneficial. It's the same as the point cloud. Why would you want to waste time to have the same result as a point cloud? Especially the Autodesk products and Tekla, they do handle very well the point clouds. So let's take advantage of the point cloud and bring it in. And this is going to be our background or our model file, and we're going to detail off the point cloud rather than a solid model. But sometimes you're like, well, it'd be nice if I could have like a best fitted plane to kind of raise my confidence in where I'm stopping my flange or where I'm going from the wall to this location. So rather than clicking on points, which can be a little bit noisy and you're not too sure, did I click in front or in the back or where exactly did I pick? This is where I find, or I say, let's find the right balance between points and modeling. So some places we may need to have like something solid to snap to or start to. So this is where we're going to do a bit of basic modeling inside Cloud Engine. So under our select tool, we got our fit points option. With fit points, we can fit geometric shapes, planes, cylinders, spheres, and edges. Really cool. So what I'm going to do, I'm noticing that maybe I was not super lined up, or there's a rework here, but I don't see the full pipe. So let's use this point cloud here. So let's say that I'd like to have this pipe here, but represented as a cylinder in Revit rather than points, because I got to put a bracket on it, and it's going to be easier if I can, design off something that's solid. So what I'm going to do under my fit shape tool, you can use the same selection tool, so you got to be cautious on how you use it. I'm going to use the paintbrush. I'm going to make it a little bit bigger, and I'm going to brush this cylinder here and brush on the other side of the cylinder a bit of points. And I'm going to ask the software to grow the selection running along that cylinder. So this is this option here. So you'll see it's going to, what did it do? This is interesting. Let me brush this here and try this again. There you go. So you see how it completed the selection. Now I've got the full cylinder that's selected. And now I'm going to say fit a cylinder in here. So it's a best fitted cylinder. So if the pipe is sagging, then it's going to be a best fitted cylinder across that sagging pipe. So it can be good or bad, but it's pretty close. We can move that object. You see that fitted object. I can go to transform If I feel like moving it around, I can do so. I'll hit the Control Z. It did work. If it, the best fit, was not really like, or I'd like to adjust it, you can turn it, whatever, but usually it does a pretty good job. So I can fit cylinders, as you can see. I go back to select, fit points. I need to, snap something to this here. I can fit a plane. So it puts a best fitted plane. So it's rather than, going off the points, as you can see that there's a bit of noise. And where am I picking exactly? Well, you got a best fitted plane here. You can go from the best fitted plane and you can go to the other edge. And let's hide the chiller. And let's see, I also need a plane in this area. So you can brush, fit a plane. You got a best fitted plane here. We can do it with edges. Let me see if I have a nice corner. We'll give it a try here. So I'd like to get the edges around here. Not sure. We don't have a whole lot of points, but I'll give it a try. So I can come here and select the points along the edges and ask the software to compute the edges. We'll see how it makes the lines for the edges. And when you have 3 planes intersecting, it creates a point. So that's useful modeling that we can bring back to our design platform as a DWG, as a reference file, and go off of those model shapes that we did, basic models that we did inside Cloud Engine. So that's basic modeling. I think I'll move on to exporting now, or sending this over to Revit. I'll show you the classic way, not using the connector. So I'd like to take this here and export it as an RCP file. You guys remember that one of the concepts we have in Cloud Engine is what you see is what you get. So what am I currently seeing? I'm seeing my chiller node right here. And if I go under points, I see 10 million points from my chiller. Is this enough? Do I want more, less points? You must decide. I'll go less, so it's a little bit quicker on the export. So I'll bring it down. What you see is what you get. This is what I'm seeing. This is what I'm going to get. I'm going to go to File, Export. It's going to open up the export tool. I can export point cloud data or polymesh. Polymesh being the shapes that we model. So let's go point cloud. You can publish either what's selected or visible. If you go selected, make sure your chiller is selected. If you want to go visible, we'll make sure that what you want to export is visible, because if you leave it like that, nothing's going to be exported. You're ready to export. You click on the export file. You get to name it. We'll call it chiller. And we can choose from RCP, which will make it ready for Revit. So you say save, and then it's going to take 310,000 points. And if I go to my root folder, PML training day 1, I got my chiller RCP file. And if you're not familiar with RCP file formats, they always come in 2 files, and they always need to be together. If you don't make them travel together, you will be in trouble. And a support folder. You see chiller RCP, chiller support. This is just the RCP file that will say, hey, you need to open up RCP recap for this file. It's got nothing. You see, it's 3 kilobytes, super small. The chiller support is the file that contains the point cloud. So in there, we have an RCS file. An RCS we can attach in the Autodesk world on its own, not the end of the world. But I often see people just sharing the RCP file. Not good. So if you guys, the guy that's going to be working in Cloud Engine and exporting for the other VDC modelers, make sure that you share those 2 folders here. All right. So I did my first export. Now I'd like to export the little planes and the edges and the things that I made. So I'm going to go back to my export menu, but this time around, I'm going to go to Polymesh. And I'm gonna go to what's visible. So what's currently visible is my edges, my cylinder, and my planes. I'm gonna say export, and I'm gonna call it chiller modeling. Hit enter, and I now have a DWG file of my model. Let's try to get dangerous here. I'm gonna fire up Rivet, and I know I have a few experts on the call, so if anything goes wrong, maybe you guys will be able to help me out. I hope you will. So as this is opening up, let me go back to our chiller here. So in this example here, if I had a display or clipping box, right, and I had it clipped around just this area like this, and I go to file, export, what you see is what you get. This is what I'm gonna get in my RCP file. Points, what's visible. If I export, and I'll just call it pipe rack, and I say save, what you see is what you get. So I had a clipping box. This is what it's going to be exporting. I had 310,000 points, but that was for the entire block. Because I made a clipping box, it's not 310,000 points that are within that block. It's a sample. It's just this section from a 310,000 grid or resolution. You get that? So I'll show you in a few minutes. I'll open this one. I usually show it in AutoCAD, but since you guys are all Revit, I'll try to stick to your world. Come on, puppy. All right. I think I have to open up a 3D view. You guys guide me a little bit. Why is this grayed out? Because I got no project open or what? I already have a project open, right?
Yeah, it looks like you have one open already.
Yeah, right. Got one open. Why can't I see any 3D views? There we go. Making progress, making projects, progress. Now, if I go, I think under insert, you got point cloud here, right? So I'll click on point clouds, and then I'll browse to my, this is demo data, my root folder, PML training, my Cloud Engine project. And now I got my chiller. So I'm going to select my RCP file and say shared coordinates. This is important here, depending on what you're doing, if you want things to line up. And there you go. You have your point cloud in AutoCAD. I could go back here and add my pipe rack. You guys are going to see that I got two models, 2 point clouds now. See, this is 1 point cloud. It's kind of shaded in gray. Oops. This part here and this part, this full object. So depending on what you're doing, if you're like, I'm doing design work on this area, I could have exported this area with a way bigger resolution and then export the overall area at a lower resolution just to check how my pipes are coming in and then where they're connecting to this. But they're at the same, they're true to each other, right? And can we attach a link CAD? I think this will work. Go back to my D drive. my computer, my D drive, Bloom, PML, training day 1, and my chiller modeling, position, shared coordinates.
The position always shared coordinates?
Hmm?
Is the positioning always shared coordinates, or how do you know which one?
Well, it will be based on how you exported your Revit model. And I think the best way to do so when you're going from the Revit world to the outside world is by using shared coordinates, right? That's what I heard, or that's how people usually go about. Because in Cloud Engine, we don't have the other coordinate systems that Revit has. So I think your best way to go about when you're exporting your IFC or your DWG is to export it from Revit using shared coordinates. And when you're attaching your point cloud is attaching it via shared coordinates, and they'll land one on top of each other. So you see now we have our edges, our cylinders, and our planes that are linked as a reference file in Revit. They're all one on top of each other. They're all true to each other.
Sorry, can I just ask a question? So those, like the cylinder and the corner of the wall there, that the objects we modeled in the cloud engine, that was the the DWG file that we just
Yep, that I
imported?
exported and I linked here as a CAD.
Okay, thanks.
So that's how you go from this environment to your designing the environment. So this was the classic way, if I can call it like that. So it was exporting as an RCP, exporting as a DWG, and then sharing, and then people attach it. At some point, I'm not sure I'm going to be able to do it. I don't think I have the latest plugin. We'll see. There's a direct connector allowing me to pull data from Cloud Engine directly to Revit. So let me go to display here and let's just slide this down here and focus on this stair here. All right. If I go back to Revit under my add-ins, I don't think I have it because it's just this Trimble Connect. Oh yes, I do. Sorry about that. There you go. So this is the direct connector to Cloud Engine. You guys remember it's a what you see is what you get. So in Cloud Engine, if you see a certain number of point, if you have a clipping box, whatever, this is what you're going to be pulling from Cloud Engine. So as soon as you click on import here, it's going to import what you're seeing in Cloud Engine. So I did it on purpose. I took my clipping box and I moved it to another location. So we get another point cloud. So if I go back here and I say from Cloud Engine, Bloom CE, Bloom Cloud Engine, desktop app, import, you just click on this and it's going to go and fetch the data from Cloud Engine and bring it to Revit. So you're skipping the export. You're skipping the export to RCP process. It's going to do it for you in the background. Connection to TC establish. I'm not sure it brought it in yet. But like I installed 2024 just a few days ago, and I'm not sure if I updated this direct connector. So that might be the connector for 2022 that I had before. So that may be why it's kind of like not working super good for me. But what we would get is the same result here, but without exporting it as an RCP file. It would be just direct in, and then if we had some modeling done, we could say export what we have from Revit, and it would send it over to Cloud Engine using the shared coordinates. I'm going to cancel it because it's not going anywhere. So like I said, I think it's my connector that needs to be updated. Because it's or it's done it really fast, which I doubt. Oh yeah, I did it. Sorry about that, guys. You see, you got one block and I got the second block right here. So I think if we go under manage, I'm not sure where I'm going, but there's a place where we can turn them off and turn them
Manage
on.
links. Manage links.
Manage links. Thank you very much. Manage links. Point cloud. There you go. So this one here, we can unload. See, now we got our two objects. Those two objects, despite the fact they're not connected with point cloud, they're true to each other. They're coming from the same point cloud from Cloud Engine with clipping boxes, but they're true to each other. You can take dimensions from one to another. You can do design. They're true to each other. Does that make sense? Yes. No. Not sure. All right. Any questions with the workflow that we've done up to now?
JP, can you quickly go through how you drew in that pipe, that green pipe that you drew in?
Sure.
Because you added the two planes after, right?
Right, exactly. So there's another pipe here in the back. So I'm gonna fit a scope box around this pipe here, and I'm gonna model this pipe here in the back. So what I'll do is go under my select points. I'll use my paintbrush, brush a few points, hit the F8 key to fit my scope box around my pipe. Gonna home my view to see my pipe in a clearer way. So I'm gonna hit the backspace here to clear my point selection. Just move this up a little bit. So this is the cylinder that I'd like to model. There's not a whole lot of points. Probably want to raise the number of points. So I'm going to go under points. This is under the chiller. So I'm going to get more points here. A few more points. Let's see if we can get just a few more. There we go. So I got more points. I'd like to model this cylinder. So I'm going to go to the select tool, fit points. I could use a paintbrush, brush the points.
Is it more ideal to bring some more points than making change the size of the points scale?
Yes, the size is just making them bigger. So sometimes it's you want to have a little bit more point. I could grow the selection. So I could click on this here and it's going to grow my selection running along that pipe. And then I could say, all right, I'm happy with this. Fit the cylinder. So this is a best fitted cylinder. You typically, if you have, I think, like half of the pipe, you're good to go. It will model that cylinder for you. You don't need to have the full cylinder for that best fit to work. So then you can go in under its properties. You see here fitted cylinders. So I could rename it to whatever, chiller, intake, or whatever. If I hit the escape key, it brings me to my object select tool, which is the default tool. I'm selected on a chiller intake. So it tells me the radius, the length, and the angle. So it's pretty flat. So if I want to make it longer, 3000, see how it extends it. So you can play a bit with that. And if you know that this is not its true radius, but it's 110, you can change it and it will adjust it accordingly. So if I release my clipping box, I can see that I've got this second pipe here that's been modeled. So they're basic tools. They're basic. They work okay. Sometimes they'll give us weird best fits, but you can try them. So if we go back to fit points, let me see if I can be dangerous. Select some points here. I'll grow the selection. Oops, I wanted to grow the selection. But sometimes when they're close to each other, it will fit the elbow. But I think this one would need to come a little bit closer, a little bit further. Let's try it here. Select these points here. Grow the selection. and fit it. No, not doing it for me. I don't know why, but in theory, it would have did the elbow. I'll have to check that, why it's not doing it. So like I said, this is where sometimes fitting a plane might be useful. So here, let's say that we need to replace, I have a good example. I don't see any connecting flanges. I guess they were covered up by some insulation, but sometimes we see where the flange kind of joins the other flange. So what we can do is, rather than going off, I don't have a good example for this, but
JP,
yes.
what are the common bugs that we have going to encounter on this application?
Cloud Engine is perfect. No, that's not true. We're being recorded here. I can't say this. You may run into some little bugs. One thing I like about Cloud Engine is that they're very proactive, and they do bring out features and updates. And if there's something missing, I reach out to them. They'll program it. They'll send me a beta version, and then it's released. But this fast-paced sometimes breaks some stuff. So we're not, under any protection for bugs or software bugs. One of the major bugs, I think, or concerns that you guys might run through or across is going to be the shared coordinates matching, moving from Revit to Cloud Engine and from Cloud Engine to Revit with the point cloud or the model.
Yeah.
That's where you guys are going to hit your biggest hurdles, I think. I do have a lot of customers, well, not a lot, but I do have customers that sometimes they say, JP, my point cloud's not landing over my model and it's lined up in Cloud Engine. What's going on? Well, they either forgot to put shared coordinates when they exported their IFC or their DWG, or they forgot to put shared coordinates when they attached their point cloud and it doesn't land at the right location. So this is where you guys are going to probably struggle the most. About 10 minutes left to our training. If you guys don't have any other questions, I could quickly show you how to take measurements inside Cloud Engine.
Yes, please do.
I did have another question.
Okay.
Yes.
Those cylinders that you modeled there in Cloud Engine, and then so we exported them to Revit or imported them. What do we do with them in Revit? Can we convert them into Revit elements, families? Like, where do we go
Yeah,
from
those cylinders here are nothing, not really, they don't have any profiles, catalog profiles or size or whatever. So they're basically just a straight flat cylinder in Revit. I don't know if you can convert them into like just family objects or whatsoever. I'm not an expert in Revit, but what I can confirm is that they're just straight cylinders. There's no profiles attached to it or whatever. It's just going to be
Okay.
straight cylinder.
So once we have the point cloud in Revit, then we will use our regular Revit families to model and just
Exactly.
like align, eyeball
Yep.
everything.
Yep. Like I said, it's really basic modeling here. You guys are not going to build a new pipe run or remodel a pipe run inside Cloud Engine. You're going to do it in Revit where you've got your flanges and your elbows and everything that you need to build that pipe run from A to Z. But if you just want to have that pipe as a solid rather than bringing the points to make sure that you're clearing when you're coming in with a new line or a new pipe run, then you can do it very quickly.
Thanks.
No worries. All right, measurements in Cloud Engine. Measurements in Cloud Engine do require a bit of practice. They're a bit tricky, but once you got it, you got the workflow going, they'll be able to provide you with measurements that are within, I'd say, 2 to 4 millimeters from reality. So if I take a point cloud, if I take a measurement in a point cloud, and then I say, all right, guys, let's do the same measurement with a tape measure when I'm in a demo, we usually are within 2 to 4 millimeters of the tape measure. on short distances, I agree, but the longer your measurement is going to be, well, the more chances the cloud measurement, the point cloud measurement is going to be more accurate, because holding a tape, it sags, you're not in line or whatsoever. So, but it does require a bit of a technique and knowledge. So the first thing that I'm going to show you guys, so under create measures, we got our tool here. We got 4 measurements that we can take. We can take a 3D dimension, so go from 1 point to 1 point. We can take a horizontal measurement, a vertical measurement, a horizontal measurement, and an angle. Angles, don't do it. It's awful. It's not an angle like we're used to seeing where you click 3 points and it gives you the angle, you know, between those 3 points from a top view. It's an angle between planes. So you can have 2 planes, 2 walls that are 90 degrees, like this, and you're like, yeah, this is a 90-degree angle. You'll click on the first plane, click on the second plane, and it's going to tell you 0. You're like, it's not 0, it's 90 degrees. They're 90 degree. No, they're at 0 because both are vertical, perfectly vertical. So it would be the angle between the planes, not the angle like this, but the angle like that. So don't play around. You can try it, but it's a mess. I don't get it. I'm a land surveyor and I don't get it. So no touch measuring angles in Cloud Engine. 3D measurements, I'm not a big fan either. I'll always prefer to go, either horizontal or vertical. That's most of the dimensions that we're looking to get. So if we go vertical, when you select the mode, one thing I like to do is do a clipping box around the area that I wish to measure. So I'm not lost and confused with points that are not needed to measure. So let's say that I want to measure from the underside of this steel member here down to the floor. Well, it's going to be a bit of a challenge to make sure that I'm clicking the underside of the beam and pretty much the same location underneath. So I'm going to do a clipping box. So quick trick here, I'm going to go from a top view. I know I want to be measuring in this area. I'm going to go to point, select points. I'm going to do a rectangle selection because I want to select from top to bottom, right? F8 to fit a scope box, backspace to clear the points, home my view. Now I got a nice clipping box of the area that I want to measure, and it's going to be like super clean. I now know that I'm doing a good measurement from the underside of this beam to the bottom here. So I'm going to go back to create, measure, vertical. And I always start with the most flat surface, because when you hover your mouse and you want to take a measurement, you hold your left mouse button down. You see how it brings this disc. This disc will line up against the normal of your point. You guys remember when I was talking about data or point cloud optimization? That's where we want to reach every time we start a job in Cloud Engine. We want to get to the optimized node, so we get points that have strong normals and that are all pointing in the same direction. You see, as I'm hovering, the disc is always flat. If I had a point cloud that had normals kicking around in all directions, this guy would be going like, woo. So measurements in Cloud Engine are always driven from the normal of the point on which you're standing on. So this is where it needs a bit of practice. So you want to make sure you drop this disc and you can see that it's perfectly flat. It's perfectly within the point cloud. So I know that it's going to take a perpendicular measurement all the way to the top from that start point. So if I go here, let me just rotate a little bit here, and then I hold my left mouse button down, you can see the data is a little bit noisier on top. You see how it's kind of like flaking, moving a little bit. So that's why you always want to start from the most flat surface up to the less flat surface, or the area, or you have the place where you have less width. So then you just click on this, and now you have a perpendicular measurement from our start point all the way up. And you can see we're a little bit offset. There's a little line here, little dotted line. Let me reset my view here. All right, so you see that dotted line? This was the center where I dropped my marker. But on the top, I'm a little bit offset it, but it's a straight line all the way up. And that dimensions is 4168 millimeters. If we were to go in the shop with a measuring tape or a disto or whatever, we'd be within 2 to 4 millimeters of the tape measure.
There's also an option we can change to English and metric.
Yep.
So we don't
you
have
just
to
need-
calculate, right?
Yep.
Oh, right
You
there.
can go right up here, reporting units, and you can switch to whatever you're comfortable with. I know that even if I switch now, oh, it does. Sometimes it stays to millimeters because it's already been taken. But you can do this. So that's a horizontal measurement. Well, a vertical. Sorry about that. If I was to take a vertical measurement, I could take it, from here to the other side. Well, I do a clipping box. I'm just not going to do it just to be a little bit more efficient. But you see how now they're kind of like noisy, the points here, depending on how they were collected and where they were collected. So I can't get my disc to be flat on the surface. It's going crazy for me. You see here, we got good normals. Oops, not all the way, not everywhere. This is kind of bad. I don't know why. So it's bouncing around. So what can we do to overcome this issue here? Because if I leave it like that and I go on the other side, you're going to see what it's going to do. It's going to be perpendicular to this disc. So if I go here, that's weird. In theory, it should have been going like this in this direction, perpendicular to this one, and then skew it. That's really weird. I'll have to check why this is happening. But one thing you can do to raise the confidence in your measurement, because this is really weird and I'm kind of like, not too sure about it. Model two planes and take the dimensions between the two planes. So I can hide the chiller, keep my planes, go back to this here. So I'm on the plane when it's black to the other side. What's going on? Not doing a great job at this, guys. Sorry about that. And it's recorded. This is the worst part of it. So from the plane to the plane. Something I'm not getting with the colors. Usually it's yellow, but what's the black all about? Let me turn the chiller back on. So we were at 1429 and now we're at 1432. So this first dimension is good, but I'd have more confidence or more faith in this second one because I went from plane to plane, best fitted planes to best fitted planes. But you can see we're 2 to 4 mils difference. And that may be true. Maybe the steel is bending a little bit. But this is how you take measurements in Cloud Engine. I could also go from this node here, this intersection. So sometimes I'll do it when I want let's say, do I have the other corner? I don't have. If I would have had this corner here, I could have do my edges and get the point. And then I go from point to point. And I'm sure that I'm not going crazy with the normals there. So that's dimensions inside Cloud Engine. The trick is to do a scope box and then make sure that your disk that's showing the normal. So if I do it again, you'll see, now I'm on the floor. I'll come around here. You'll see it's going to turn and now it's on the wall. So you see it's on the other wall. So you're always working with the normals, the points normal. So that's you want to make sure that you have a good normal to take your measurement. Time's up. Any questions?
JP, can you just quickly go through how you created that clipping box again, please?
Yeah, sure. So let me hide the measurements so they're out of the way. So there's different ways to go about for creating a clipping box. One of them is doing it via selection action. If I want to create a clipping box around this object here, I select the chiller object, I go to display, model view, and when you reset the view, because you've got something that's selected, it's going to reset it around your selected object. So if I wanted to do a clipping box between those two planes here, I could come here and select the two planes and say fit the box. You see how it's now fitting around my selection. So then I can clip, and I've got a clipping box around my selected objects. So this is the first technique, is a selection action. Select the object, fit the scope box around, clip it. You can do manual, like I showed you guys, or you can go with a point selection and the F8 shortcut key. Sorry. So if I want to do a clipping box around the stairs that we have here, I would go to select points, use my paintbrush here, and I know I want to go from here. I want the bottom of this stair, and I want all the way up to the top here, like this, and then hit the F8 key on my keyboard, and it's going to fit a scope box around my point selection. So I got some points here at the bottom and at the top, and there you go. You got your point selection around your objects that you were looking to get. And you can adjust them if you want to. Or like I did with the other one, I knew I was going from the underside of this beam to the floor. So I went to a top view, and rather than using my paintbrush, I did a box selection, because when you do a rectangular selection, it selects the points across the entire depth of your view. So you can set out points on the floor, points on the beam, F8, backspace to clear the selection, and I've got my clipping box created. Any other questions? All right, so I've stopped the recording.